In this video, I'd like to explore the ideas of ratios and proportions. First, what is a ratio and how to simplify them? And then secondly, what is a proportion and how do we solve them? So first we see a ratio is, or in other words, the ratio of A to B is equivalent to a fraction where A is being divided by B. So I can see here, if I say the ratio of one thing A to a second thing B, that's really saying the first thing A is being divided by the second thing B. We can also see that this ratio can be written as A colon B, which is just another way of saying the ratio of A to B. Many ratios that we're given can actually be simplified further than their immediate form. In order to do this, we first need to convert all values in the ratio to the same units. Now, this doesn't necessarily mean there's one correct way. We can either convert the top or the bottom in terms of the same units as the other one. And we'll see this in just a few examples. Second, we then want to identify our largest number that divides both the numerator and the denominator once the units are the same. And remember that this largest term is called the greatest common divisor. And then we're going to simply divide both sides by this greatest common divisor, or in other words, the greatest common factor. So here we see a ratio of $65 to $15, or in other words, 65 divided by 15, and I'm asked to simplify here. Now we notice that they're already in terms of the same units because they're already both in terms of dollars. So we don't actually have to put them in terms of the same units for this case. Instead, we simply have to try to simplify the ratio. Now what this means is I'm really trying to break this up into two fractions, one of which is equivalent to 1. So if I look at 65 and 15, I recognize that both of these are divisible by 5. So in other words, I can break this off into 5 over 5 times the top value. 5 times 13 is 65. And the bottom value, 5 times 3, is 15. So as I simplify this, what I'm really doing is recognizing that 5 over 5 is equivalent to 1. And I don't need to multiply by 1. So in other words, I'm recognizing that our simplified ratio is simply $13 divided by $3. So in other words, we're pulling out the largest number that divides both the numerator and the denominator, simplifying, and then recognizing that the simplified ratio would be 13 to 3, or in other words, 13 divided by 3. So again, I could write it as 13 divided by 3, or 13 colon 3, where both of these are in terms of dollars. In our second example, again, I want to simplify this ratio of 8 feet to 10 inches. Now, there's two things we want to recognize here. First of all, they're not in the same unit, and then also they're not written as a fraction here. So the first thing I recognize is that I have feet and I have inches. I either need to convert feet into inches or inches into feet. Now, I often think it's easier to take the larger unit and make it smaller. So between feet and inches, I recognize that feet is the larger unit. Now, in order to think about this logically, if I start first with just 1 foot, I should know that 1 foot is 12 inches. So if I have 12 inches, that's the same as 1 foot. Therefore, 2 feet should be 12 inches times 2, or in other words, 24 inches. And then same idea, 3 feet is really 36 inches, where I'm multiplying 3 by 12. So hopefully at this point we're recognizing a pattern. In order to find the number of inches in a given number of feet, I have to multiply by 12. So I'm going to convert this. First, I'm going to change 8 feet into 8 times 12, and this is now going to be in terms of inches based on the pattern we just observed. And now the denominator is still 10 inches. So I've rewritten it as a fraction, and now also they're both in terms of inches. So I recognize that 8 times 12 is really 96 inches over 10 inches. So again, we took the 8 feet. We recognize that feet is really just 12 inches. So 8 feet is really 8 times 12, or in other words, 96 inches. Now I just need to simplify both of these. Now I recognize that 96 and 10 are both divisible by 2. So I can actually break this down into 2 over 2 times, well, 2 times 48 is 96, and 2 times 5 is 10, and I can just basically say that that 2 over 2 divides to 1, or in other words, I don't need it. So my simplified answer then is 48 inches to 5 inches. Now here's a final example, 3 gallons to 20 quarts. Now if you remember, there are 4 quarts in a gallon, so I can again look for the pattern here. If I have 1 gallon, that means I have 4 quarts. That means that 2 gallons would be 8 quarts. And also that 3 gallons, which is what I have in this example, is 12 quarts. So I'm looking at this because the first thing I always need to do is make sure that my units are the same. Right now, gallons and quarts are not the same, but based on my little pattern I noticed here, if I have 3 gallons, that's really 12 quarts. I can change this into 12 quarts on the top of my fraction over 20 quarts in the denominator. So I've changed the ratio to a fraction, and I've also changed the 3 gallons in terms of quarts, so now I have a common unit. Now I simply need to simplify. I notice that 12 and 20 are both divisible by 2, but they're also both divisible by 4. So I'm going to pull out a 4 over 4 times 3 over 5, and those are both in terms of quarts, so 3 quarts and 5 quarts. And since 4 over 4 is just equivalent to 1, we don't need to write the multiplication by 1. So I recognize then that my simplified answer is simply 3 quarts to 5 quarts. And again, I know that this is completely simplified because 3 and 5 do not share any more common divisors. So moving on from ratios, we can now talk about, well, what is a proportion? Well, a proportion is an equation that states 2 ratios are equal. So remember, a ratio is just really a way of saying one thing divided by another, or one fraction. So here I have one fraction being equal to another fraction. So again, 2 ratios that are set equal to. A over B is a ratio, and C over D is another ratio. A proportion, again, just setting 2 ratios equal to each other. Now, in terms of solving a proportion, or in other words, 2 ratios set equal to each other, we can solve these simply by what's called cross-multiplying. Or in other words, I can multiply A times D, and I can set this equal to B times C. Now, before we take this for granted, though, what I want to recognize is why this is true, and it all goes back to what we were talking about in previous sections, which is solving literal equations. What I'm really doing here, and this is kind of cool, is I'm doing inverse operations to eliminate the denominators on both sides. So the first thing I'm doing is multiplying both sides by d over 1. And the goal here is that I want to eliminate the division by d on the right-hand side. So multiplication and division divide to 1. Now, what else do I want to get rid of? Well, I want to get rid of the division by b, so I multiply both sides by b over 1. And I recognize that this is then canceling. Well, multiplication and division by b cancel on the left-hand side. This is how we see that all that we're really left with is the cross multiplying. See how I have a times d, which is the cross multiplication. And then over here, I have c times b, which is again simply the result of our cross multiplying. So cross multiplying, yes, is a really great way of remembering how to solve a proportion, but we really want to recognize that this is just a quick way of remembering that we're really multiplying both sides in order to cancel the division that we see in a proportion. So here's our first proportion that we want to solve for x. 3 over 7 equals x over 21. And in order to really drive that point home, we can really show what's happening here. I'm going to rewrite this. 3 over 7 equals x over 21. If I want to solve this proportion, I told you that the shortcut was to cross multiply. Or in other words, I can multiply 3 times 21. So I'll write that out first. 3 times 21 is my first cross multiplication. And I can set this equal to the second cross multiplication. 7 times x. So 7 times x. Now what I notice is if I simplify, this gives me 63 equals 7x. And now if I do the inverse, in other words, if I solve this equation, the inverse of multiplication by 7 is division. So if I divide both sides by 7, 63 divided by 7 is 9, and that's equal to just x, because 7 divided by 7 is 1. So here's my answer. X equals 9. Now, a quick way again of just proving, well, what really happened there. Let's just do that quick cross multiplication over here again, but let's actually do it outright this time. If I'm solving for x, what I really want to do is just get rid of this division by 21. Well, how do I do that? I do that by doing the inverse of division, which is multiplication. So if I multiply both sides by 21 over 1, I can see that I'm going to end up with, on the left-hand side, 63 over 7, right? 21 times 3 is 63. 1 times 7 is 7. Equal to, well, 21 times x is 21. X over 21. But if I simplify these, I notice that 63 over 7 is just 9. And 21 divided by 21, I'm left with just x. I get the same answer. I can see here, well, this cross multiplication trick I showed you really is nothing more than just applying that inverse operation to both sides. What we're going to notice, though, is that cross multiplying is a little bit faster as we get to the more difficult problems. So keep this in mind as we move forward. Here's another problem. We can see it's getting a little bit more difficult. I have an entire equation now in this proportion where I have 6 over 15 equals to 2x minus 4. But since we saw in our last problem that all I need to do is just cross multiply, I'm going to go ahead and do that. So first I'm going to multiply 15 times 2x minus 4, and be careful here. Since I have more than one term I'm being multiplied by, I am going to put parentheses up to remind myself that I have to distribute that 15 across to the 2x and to the negative 4. This is now equal to, well, I got to do the second cross multiplication, 6 times 60, which gives me 360. So now we're just left with a more difficult equation that I need to solve. I have two options here. One option is that I could distribute the 15 through, which a lot of people seem comfortable with. Or remember, I could just do the inverse of the multiplication by 15, which is division. But let's just go ahead and distribute. 15 times 2x is 30x. 15 times negative 4 is negative 60. And this is equal to 360. So if I solve this equation, I have to do the inverse of the subtraction first. Remember, inverse of PEMDAS. So I'm going to deal with the subtraction before the multiplication. I'm going to add 60 to both sides. This is going to give me then that 30x is equal to 360 plus 60, which is 420. And then to finish solving, I need to do the inverse of multiplication, which is division. Recognizing that multiplication and division by 30 divide to 1. And I'm left with my answer over here, x equal to, well, if I do 420 divided by 30, this is a little bit of a tricky problem, but we can logic our way through it. I know that 30 times 5 is 150, and 30 times 10 is 300, so I'm just going to go up from there. 11 would be 330, 12 would be 360, 13 would be 390, so I'm looking for 14 to be 420. Just counting up by 30s there. So here's our solution. Now, it's always nice to double check that we've done this correctly. So remember, I can always check my problems when I'm done by plugging in the solution. That's still true even for proportions. So let's go ahead and check our answer here. I'm going to plug in And if I basically do 6 over 15 equals, I'm going to do 2, but instead of x, I'm going to do 14 minus 4 over 60. I want to check this. So I'm hoping that with the right-hand side is going to simplify down to 6 over 15. Let's see. 2 times 14 is 28 minus 4. This becomes 24 over 60. And I can simplify the 24 over the 60 because those are both divisible by 4. So if I pull out a 4 over 4, 4 times 6 is 24, and 4 times 15 is 60. I notice that the 4 over 4 just divides to 1, and I've checked and concluded that, yeah, this is true because both sides just simplify to 6 over 15. So you don't always have to check and simplify, but it's a good way of making sure you're on the right track. And here's another problem, again a little bit trickier now because I have actually two different equations that we need to solve for that given value of x. But again, as long as we remember cross multiplication, these proportions can look difficult but aren't that bad to solve. I'm going to first cross multiply 6 times 12x minus 2. And again, I want to be careful to put parentheses around the 12x minus 2 to remind me that not only is 12x being multiplied by 6, but so is the negative 2. Or in other words, I'm going to have to distribute here. Now what is this equal to? Well, that's our second cross multiplication, which is 10 multiplied by, again, parentheses, 3x plus 3. And again, the parentheses are reminding me that 10 is not only being multiplied by the 3x, but also the 3. So now we're all set to distribute. 6 times 12x is a 72x. 6 times negative 2 is minus 12, equal to 10 times 3x is 30x, and 10 times 3 is 30. So I need to combine some like terms here, and the problem is that my like terms are on opposite sides of the equation. I have 72x and I have 30x that are like terms, but they're on the wrong side. So I'm going to bring the 30x over by applying the inverse of a positive 30x, which is a negative 30x to both sides. And I notice that this is going to leave me then with 72 minus 30, which is 42x, minus 12 equals a positive 30. Now the problem is I need to get rid of the 12, so I'm going to go ahead and add 12 to both sides. Inverse of that subtraction, trying to get the x by itself. This is going to give me 42x equals 42. And then finally, to finish solving here, the inverse of the multiplication by 42 is the division. And this actually works out pretty nicely. Both of those are simply going to divide to 1, or in other words, my solution here is that x equals 1. Good. And as a quick check, I can plug in, and if I do 3 times 1 plus 3 over 6 equals to 12 times 1 minus 2 all over 10. If I simplify, 3 times 1 is 3 plus 3 is 6, or in other words 6 over 6, and this is equal to 12 minus 2 is 10 over 10. Since those are both equal to 1, I can say that yes, this did definitely work. Okay, one more proportion to try here. We'll go through this quickly. I again need to cross multiply. So I'll first cross multiply 5 times 8x plus 6. So if we set this up as 5 times 8x plus 6, I then set this equal to the second cross multiplication, or in other words, equals 13 times 2x plus 7. So I'm going to distribute through. 5 times 8x is 40x, and 5 times 6 is 30, equals, distributing through again, 13 times 2x is 26x, and 13 times 7, a little tricky, that ends up being 91. I'm now going to solve the equation. I need to combine my x terms, so I'm going to subtract 26x from both sides in order to bring the x terms together. And this is going to give me 40 minus 26, or in other words, 14x. plus 30, and I'm just left with 91. So now to finish solving, I notice that if I bring that equation over here, I have 14x plus 30 equals 91. I need to get x by itself. I have multiplication by 14 and addition by the 30. By inverse PEMDAS, or opposite order PEMDAS, I need to first deal with the positive 30 by subtracting 30. This leaves me with 14x equal to a 61. And then finally, to deal with the 14, since that's being multiplied, I apply the inverse, which is division. The 14 over 14 divides to 1, and we're left with the answer x equals 61 over 14, which unfortunately cannot be simplified. 14 is only divisible by 2, 7, and 14, none of which are going to divide the number 61. So we're unfortunately stuck here as our final answer. And because this is such a messy fraction, I'm going to trust that our algebra is correct and not plug this in. So for homework tonight, I have some on-your-own problems to try on your own. So work through simplifying ratios and then solving proportions, and we'll check back in next class.